Alright, ladies and gentlemen, this will be the first lesson for section 1-2. And in this lesson, we're going to talk about identities and inverses. Now, our first objective is to be able to explain what an identity and an inverse is for any operation. So just kind of in general, what is an identity, what is an inverse? And then we're going to talk about identifying the additive and multiplicative identity and inverses specifically. So the key is, what are the additive and multiplicative identities and inverses? So to start off with, let's talk about what is an identity. Well, if I look at this dog here, my puppy here, he's got his glasses on, he can see very well. We're going to try to identify what is the visual identity. Well, visually, if the puppy looks out and I put a plane in front of him, what does he see? He sees an airplane. So, what if he looks out and he sees a pineapple? Well, if I put a pineapple in front of him, his eyes are going to see a pineapple. Visually, he's interpreting a pineapple in front of him. Let's say we got rid of those two guys. And now, this time, in front of the dog, we're going to put a mirror. Now, when the puppy looks forward at the mirror, he sees himself. So we can kind of state that the visual identity is a mirror in this case. When this dog looks at a mirror, he sees himself. And this is the concept that we're going to use when we talk about our additive and multiplicative identity. So the first thing we're going to talk about is our additive identity. Our additive identity. And I use number 5 a lot, so we'll start with number 5. It's a good number. If I look at the number 5, and I want to find the additive identity, I'm asking myself, what could I add to 5 to show it itself and get 5 in the end? Just like when the puppy dog visually looked into a mirror, it showed itself to him. So what can I add to 5 to show it itself? Simple algebra tells us it's 0. We can only add 0 to 5 to show 5. Let's try a different number. What about 8? Well, 8 plus 0 equals 8 again. So 8, I add 0, I show it 8. When I add the identity, I should show it itself. That works, and I could generalize this statement to say a plus 0 equals 8. So my additive identity is 0. Now, let's talk about multiplicative identity. You may ask yourself, well, we already identified what the identity is. It's 0, right? But the key to these identity and inverse concepts is that they are dependent on the operator. So a different operator, multiplication here, will have a different identity. The multiplicative identity, again, we can use our good friend number 5. Use a different color though. 5 times something equals 5. What do I multiply by 5 to show it itself? I multiply it by 1. Well, what do I multiply 8 by? To show it 8. 8 times what? Again, it's 1. And it turns out that the multiplicative identity is the number 1. I can multiply any number a by 1, and it will show itself, a, again. So the multiplicative identity is 1. Now, the key thing to take away from this, ladies and gentlemen, is that the identity depends on the operator that we're talking about. The additive identity is 0, but the multiplicative identity is 1. And we can have other operators out there, and we're not going to go into all the different operators there are. We want you to be familiar with the additive and the multiplicative identity and the general concept of what the identity is. So, what is the inverse then? Well, if the identity shows a number itself, the inverse takes us back to the identity. So let's look first at the additive inverse. And I'll abbreviate here. The additive inverse. Let's go back to our good friend number 5 here. If I start at number 5, what can I add to the number 5 that will take me back to the identity? And remember, the additive identity was 0. And if I start with the number 8, what can I add to the number 8 to take me back to the additive identity? 0. In general, I want to be able to start with A and add something and get back to the identity, 0. So this column would be my inverse, and this column will be my identity. So what could I add to 5 to get back to 0? I have to add -5. That takes me back to 0. And what would I add to 8 to get back to 0? I would need to add -8, and that would take me back to 0. So for my additive inverse, it's going to depend not only on the operator addition, but also on the number that I start with. The additive inverse for 5 is -5. That's what takes me back to 0. The additive inverse for 8 is -8. That's what takes me back to 0. And we could generalize it again that the additive inverse for any number A is -A. And that takes me back to 0. You guys probably can see where we're going now when I talk about the multiplicative inverse. All right, with the multiplicative inverse, again, if I start with my number 5 here, what could I multiply 5 by to get me back to the multiplicative identity, which is, yep, it is 1. And what can I multiply 8 by to get me back to the multiplicative identity, which is 1. And what can I multiply any number A by to get me back to the multiplicative identity of 1? Well, if you guys think about your fractions, which I know you love because every student loves fractions, if I have 1/5 and I have 5 of those all put together, I end up with 5 times 1/5, which is 5/5, which equals 1. And if I have 1/8, I multiply 8 times 1/8, and I get back to 1. And in a more general sense, if I multiply any number A by 1/A, it leads me back to 1. In the same fashion, we have the identity here, and here is my multiplicative inverse, 1/A. And sometimes we hear a little bit of laziness happening, and we, in general terms, if we say the inverse of 5, 99% of the time we're talking about 1/5. But it's always better to be more explicit and say the multiplicative inverse of 5. It is actually the reciprocal of 5, 1/5. So the multiplicative inverse of any number is its reciprocal. If I multiply A by its reciprocal, 1/A, I result in 1. So let's talk generally a little bit broader here on another concept of inverses. Inverses are a way to undo an operation. So the inverse of addition is subtraction. If I wanted to undo addition, I would subtract something. And what is the inverse of multiplication? The inverse of multiplication is division. That is how I would undo multiplication. Now notice my wording difference. Here I'm asking what's the inverse of multiplication. The inverse operation for multiplication is division. What is the multiplicative inverse? It is the reciprocal of the number that you're multiplying by. So again, the inverse depends on not only the operator, but the number we're starting with. The inverse depends on not just the operator, but the number we're starting with. And the identity depends on the operator exclusively. It's the same thing for any number. The additive identity is 0 for all numbers, and the multiplicative identity is 1 for all numbers.